Hi, everyone, and welcome to another webinar hosted by Promess Incorporated. My name is Ed Stockline. I'm the North American Sales Manager here at Promess. Today I have with me Gibson in sunny Florida. Gibson, you want to introduce yourself?
Hi everyone, I'm Gibson Kramer. I'm an application engineer here with Promess. Throughout our conversation today, if you guys do have any questions, feel free to add those into the chat box and we will get to those at the end of the show.
Yep, so today the title of the webinar is Getting Pressed for Results. So a little summary of kind of our conversation. We did have this conversation a few days ago and we pre-recorded it, so we'll get to that in just a second. The main idea of this is to everybody's up against results in the manufacturing world. So we're going to give some scenarios and some examples of a couple of things that maybe you think about or don't think about when choosing equipment that is right for your company, your assembly line, your product, on what you're trying to manufacture. So we're going to dive into that conversation. One other housekeeping thing, there will be a flyer available that has some links to other resources that you guys can download at any time. And like Gibson mentioned, if you do have questions throughout the webinar, just throw them into that chat and we'll answer them towards the end of the video. But we'll go into the recording and come back for some questions in a minute.
So the first topic that we're going to talk about today is the direct costs, and the first cost that we're going to talk about in that topic is the energy costs for different types of press technologies. So there was a study done a few years ago by a university in Europe that compared kind of the energy consumption of electromechanical actuators compared to hydraulics and pneumatics. And Gibson has some of the specs from that study and some of the results that they came up with during that. So what do you got, Gibson?
Yeah, for sure. So for this study, they had three similar spec systems, 3 cylinders, 1 air, 1 hydraulic, and 1 servo. These all had the same force capacity and stroke. For the specific test, they were raising a 1,000 Newton weight, so 1 kilonewton, and they're raising that 50 centimeters. So all of the cylinders were doing the same amount of work in this study. Now it should be noted that this can be used as a baseline, but if you are lifting different weights in different scenarios, different operations, you may have varying results. But for this example, for the hydraulic compared to the servo or the electromechanical press, the hydraulic system used 4.4 times as much energy to do the same test, raising that weight. For the pneumatic system, that used 10.3 times as much energy to raise the same weight as the servo press.
That's crazy.
A lot of this comes down to having to maintain that pressure with a pump so that you can actuate the cylinder on demand. So when you want to start moving a cylinder, whether hydraulic or pneumatic, you have to have that pressure already built up, which means you're constantly running that pump or that motor to be able to build up that pressure. And of course, that takes energy.
Yep. And when you're comparing, say, the cost of that equipment, obviously the electromechanical solution usually is quite a bit higher than either a hydraulic or pneumatic type solution. But the cost of whatever application that you're looking at for an electromechanical, you're going to be talking about a project that might last 8 to 10 years. So the energy consumption over a longer period of time or a longer time horizon is much more important on those longer projects if you're planning on using something for a multitude of years.
Yeah, it might seem like a trivial difference up front, but once you factor in the term of that project, then it becomes a lot more significant cost to the project.
Yep. And then the next kind of subtopic in the direct costs is directly related to the longer periods of time that we're using these actuators in, say, a production scenario. So when we're thinking about that, one of the things that comes up is the maintenance cost.
Yeah, for
So
sure.
typically, for any type of maintenance on a particular system, what would be kind of the main maintenance points that we want to highlight here?
So for a electromechanical system, it's essentially just greasing, typically about every quarter, and then we also have a calibration if we are incorporating our load cell in that. Now, when we compare that to a hydraulic or a pneumatic system, with those types of systems, you have a lot more devices that need maintenance. So you'll have the cylinder itself, a tank, the fluid or the medium, as well as the pumps. And those all have their own seals. So the pumps, all the piping, and the cylinder itself will all have seals that may degrade over time that you will have to perform maintenance on. And a lot of times that includes taking the cylinder off the line to do that maintenance or repair. Another thing is maintaining the medium. So that's either the air or the hydraulic fluid. For the air example, you have to filter that air and dry the air so that it can last longer for your equipment. And same with the hydraulic fluid, you have to maintain that fluid, constantly filtering it, maybe replacing it as well to try to increase the longevity of that system.
Yep. And you kind of mentioned it there for a second. Certainly the downtime becomes a factor with the maintenance costs, right? So if you do have to, say, pull a unit off the line to maintain it, you either have to have a secondary unit to replace it to keep the line up and running, or you need to have the line down for a particular amount of time to do the necessary preventative maintenance on that unit. Yeah. So the just to recap, the electromechanical grease and a yearly calibration, and then obviously with all the components wrapped up in a hydraulic or pneumatic system, the high maintenance costs can be pretty substantial over the life of a system. If we're talking like a typical automotive project, which could be anywhere from 8 to 10 to, depending on how long they want to run maintenance parts for, 10, 15 years, those maintenance costs over time really start to stack up, especially if you have to have multiple units to keep the line up and running. Because now you're basically doubling your investment for essentially half the capacity, right? Because one's going to be sitting on the shelf most of the time.
Still need to maintain that as well. Those seals are going to go bad just sitting on the shelf. So,
Yep.
And you're maintaining both systems, even if one's a spare.
Yep. So the third topic related to direct costs is some of the environmental health and safety issues that different press technologies need or you run into with different types of technology. What would be some of the EHS costs that would go into different types of technologies for press systems?
Yeah, so one of the first things to consider is the noise level of the system. So servo presses typically run much quieter than either a hydraulic or a pneumatic system. A lot of that noise is coming from the pumping action or the pressurization of the medium. This noise reduction can actually put you guys in your facilities below a threshold where earplugs are required. So you're able to eliminate the cost of earplugs in your facility, as well as reduce your insurance costs because now you're not contributing to hearing damage in your facility. And it genuinely just makes it a nicer environment to work in when you don't have to yell to each other to get a message across.
Right.
Another big factor in that is the hazard nature of hydraulic fluid. The two main forms that it comes in are either highly corrosive or highly flammable, and this can cause big issues when you're trying to mitigate risk in your facility, but you're also bringing in these chemicals with these inherent risks to them. Another big point on that is that if you have a hydraulic system and it's leaking at all, then you have a slip hazard on your shop floor. So that can, again, increase risks, and it also increases the cost to maintain these systems. You're constantly soaking up that hydraulic fluid or putting kitty litter on it to try to mitigate the issue.
Yep. So we've talked a little bit about direct costs related to servo presses, which are not servo presses, but all different types of press technology. The next thing, which is a little bit harder to quantify, the direct costs are easy to put, say, in a spreadsheet and say, yep, this one's definitely cheaper than that one. But something that you have to consider when you're thinking about what technology you want to go with is the indirect opportunity costs. So we've got a couple examples here. The first one is actually going to be an example of throughput. So what's throughput, Gibson?
Throughput is how many parts you're producing typically every year, and those are the parts that are making it to the customer.
Yep. And that is basically kind of a measure of your total capacity minus any scrap or quality issues and what actually gets out to the end of the line.
Exactly.
Right.
Yep.
So the indirect costs associated there with throughput is, what happens if you can't serve your customers by either not making the throughput that you need to in order to make a shipment, not being able to get shipments to your customers on time, not being able to produce those parts fast enough to sell fast enough to your customers. Those are all kind of costs that, while easy to say calculate in your ROI spreadsheet or whatever you're doing to estimate how much a system is going to cost you versus how much it's going to make you. Throughput is usually, when you're estimating it, is also, it's in a perfect vacuum.
Right, it's theoretical at that point.
Yeah, it's theoretical. So the biggest problem with that is you can make an estimation or a theoretical estimation of that throughput,
Right.
but what happens when you have downtime, or what happens when the system that you have is undersized and you're not able to make rate?
Right.
So if you're just coming in, you do have to have a level or a safety factor kind of built into whatever system that you're doing, but rarely do people ever get that right out of the gate, especially when considering different size systems. The next kind of indirect opportunity cost that we were talking about was your business needs to make investments in order to stay competitive. So if you have, say, a customer coming in to visit your facility and you've been around for 100 years and all of your press systems in there are 80 years old, yes, you've earned the ROI on them probably by having them that long, but what does the impression of, say, a bunch of old hydraulic systems on your floor look like compared to maybe a more state-of-the-art facility? Maybe your customer is more technologically advanced and you're trying to, say, impress them on a tour or something like that. If you're not making those investments, you're gonna have issues in the future, maybe trying to get new business, trying to maintain old business as well. I guess one other thing that would be related to that is maybe the data collection on a system, right? So if you're using a really old system, what would be a major factor of collecting data for an investment like that?
Yeah, so a lot of companies nowadays want to see that traceability in your part so that they can look back and make sure that everything was within acceptable parameters on that specific day at that specific time, and what factors can be taken to mitigate the risk that it happens again. So that traceability in your process can be a big factor in staying competitive in this market.
Yep. Also, if there's quality or warranty issues with your customer and they come back to you and say, hey, what's going on here with this process? If you're going back to an old hydraulic press that doesn't have any monitoring or has no sensors on it that can give you sort of any indication into that process,
Right.
You're gonna have a hard time kind of proving to your customer that problem or that issue won't happen again.
Definitely.
Which could cost you more business depending on the types of customers that you're dealing with.
Having that data collection definitely inspires confidence with your end customer.
Giving them the confidence too, right? So I guess that kind of goes into the next portion, which is talking a little bit more about part quality and warranty as well.
Yeah.
So in this day and age, what issues with warranty or part quality, what effect does that have on cost in terms of a project?
It's hard to see it right away, but once you are producing parts that are lower quality, your customers are gonna know. And with the internet and social media nowadays, if your good customers are realizing that your quality is going down, then they're gonna let people know about it, right? So it's a lot about protecting the image of your brand and making sure that good parts are making it to your customer.
Yep. So you dirt bike, don't you, Gibson?
I do.
You
Yep.
do dirt bike?
Yeah.
So what's one of the first things when you're looking at a part online? What's one of the first things that you look at when you're trying to find that new part?
For me, it's mostly about reliability. So on my dirt bike, I'm going fast sometimes, and I want the parts that I'm using on that to be top quality and to not have any thoughts about those parts failing on me. I want the confidence in those parts, and what I'm doing to gain that is reading reviews online, seeing what other customers had experience, and I want to make sure that I am getting a similar experience. So really, consistency in those parts and having good feedback from the other customers that are using them are important to me when I'm getting parts for my dirt bike.
Yep. Yeah, and another factor to consider there, especially for those of you that are manufacturing things that are a lot closer to consumer markets, right? You might make a product that has a quality issue that at the end of the day might not be that big of a deal, but someone spends X amount of dollars, thousands of dollars on a new dishwasher or a new appliance type of thing. If you have, a squeaky part in there or something like that, that quality issue is going to go on the internet and people are going to be talking about it. And whether it shows up in a review or in a Facebook post or something like that, that's a huge issue with brand recognition and those types of things. You don't want to be kind of labeled as that company that doesn't have very good products. So that is a lot harder to quantify in the grander scheme of things, but certainly for global and international companies, any sort of bad reviews about a particular product can really drive away new potential customers to your product line for those issues in particular. So the third and final topic that we'll cover today is a little discussion on ROI. Every business has kind of a different target for ROI. I think most of our customers generally are just under the 2-year mark for most systems that we're providing them. And the direct and indirect costs are a huge factor in the ROI for those systems. A lot of the examples that we typically deal with, scrap rates are a big problem with a lot of our customers. Quality issues are a big problem with a lot of our customers. So all of the systems and sensors that we use and process are there to mitigate the issues that our customers are having with quality, the performance of their products, and those types of things. But they all have that direct and indirect costs associated with them. One case study for a customer that we have, we'll talk about right now, just as an example of how we can mitigate the scrap costs for that particular customer. So this particular customer, they have a volume for this particular part model of 250,000 units per year, which has about, before the Promess system, about a 5% scrap rate. So that comes out to about 12,500 units per year. And at about $3 per part, they're looking at about $37,500 per year of scrap costs just basically going into the garbage. So one thing that we were able to do for them was reduce that scrap rate to almost nothing And in turn, the system that we used for that particular example, we actually basically paid it back within a year or so, based off of the results of getting that scrap rate down to zero. We also have some other examples of different types of customers. So in the automotive field, for example, if you don't make rate, so that going back to that throughput point that we made earlier, if you keep a OEM from getting a car off the line, what does that OEM charge typically? Like $7,000, $8,000, $9,000, $10,000, depending on what type of product that you're keeping them from getting off the line. So depending on those types of factors and the quality issues that you may be having, say with a hydraulic or pneumatic system, there really can be some substantial savings when you're talking about all the factors involved with costs, indirect and direct both.
Definitely.
Is there anything else that you wanted to talk about?
To sum it up, when you are making these big decisions, it is always very important to not only take in the direct costs, but definitely consider these indirect costs as well, especially over the lifetime of a project, and to see what makes sense for you at your facility, whether it is servo or maybe it is a hydraulic or pneumatic. But definitely consider all these different factors when you're making those decisions.
Yep. And if you do have any issues that you wanted to talk about, maybe you have an application where your scrap rate is super high, or there's a quality issue with your part, either caused by a hydraulic pneumatic system or even a potentially like an undersized servo system for sure. Feel free to call Promess, talk to one of our expert application engineers on your specific application. We should be able to have a conversation about, what is the right equipment for your particular application. And then we could even test your parts here at our facility to figure out, what size press you would need in order to, say, accomplish and get the results that you want.
So we're going to go to some Q&A.
back.
I think we have a couple questions. The first one I'm going to throw at you, Gibson, if you're ready.
All right.
So the first question is, how can I figure out what system requirements I need to upgrade to servo technology if I don't have any data to show for my old systems?
Yes, great question. So right at the end there, we touched on the process development center. So if you don't know the force specifications or the torque specifications for your specific application, then send those parts into our process development center, or you're welcome to come along with the parts and we can run those parts on our stations in our laboratory and then give you guys that data so you can make more informed decisions before you ever write a PO.
Yep, and that's just kind of another little value add thing that we do. We want to make sure that you as a customer are happy with the potential process that you're building, and the PDC allows us to really make sure that our presses are capable of doing the process to your satisfaction, but also giving you that confidence that that process will work out for your investment in us. Second question is, what are the lifespan of these investments? What is the lifespan of these investments? So I guess that's in general, most of the capital equipment that we're talking about usually has, a 8 to 10 year lifespan in terms of, a typical automotive project or something like that. It really just depends on all the factors related to the application at hand. If you are a company that has kind of a quick development cycle where you're maybe purchasing equipment every couple of years for new products that you're launching, you might have a shorter lifespan depending on the end of life of your own products. But for something maybe a larger development like an automotive transmission or say an electrical product that may be used for 10, 15, 20 years, I don't know if we talked about it in the video. One of our earliest applications, making some O2 sensors with one of our presses, is still, it was one of the first presses that we sold here in the U.S. and that machine is still running today. So we're coming up on like 35, 40 years of life for that system, and has literally made hundreds of millions of parts over the lifespan of it. So, and that's with just the maintenance that we kind of discussed in the recording of calibrations and the greasing that we require for the preventative maintenance stuff. Do you have anything else for that, Gibson?
I think you covered that pretty well, Ed.
So it doesn't look like we have any more questions, so we'll wrap this up. Just as a reminder, you can download the webinar flyer from some menu on the side, I'm sure, which does have some links to the resources that will give you a little bit more information on the EMAP and some of our blog posts and things like that, help you start building your case for moving to a better technology. If you'd like to reach out to us and find out a little bit more about presses, torque units, motion control systems, workstations, any of those products, you can reach out to us at 810-229-9334 or put in a web submission on our website at promessinc.com. Thanks for joining us today, and we'll see you next time.
Thanks, everyone.